Hello folks. Okay, now we're going to look at coefficient of friction, looking how to use this coefficient to determine force of friction, or what we call normal force. Now, a lot of this has to do with interpretation of the question, and this is where we do some of the practice. Now, the equations that we're going to use, here's the coefficient of friction. It could be either static friction or kinetic friction. Doesn't matter which one, but the equation is the same. Friction is in the numerator, and the normal force is in the denominator. Now, as I said, to refresh our memories from the lecture, is the surface. I have an object on the surface. The weight, mass times gravity, is pushing on the surface, and there's an equal and opposite reaction of the surface pressing on the block, and this is what we call the normal force. And it's this divided into the force of friction, gives us this coefficient of friction. This is basically how much interaction between the surface and the object we have when something's been trying to push. More friction, harder it is to push. Less friction, easier to push. Hopefully that will make sense. Now let's look at this question. We got a ship that's launched from a die dock, slides into the water, constant velocity. So if the boat is going this way, force going back, friction is slowing it down, and it's equal and opposite of the force going to the right, forcing it down the slide. Suppose the force of gravity that pulls the ship downward along the dry dock. This is important. This text that pulls the ship downward along the dry dock is 4.26 times 10 to the 7th Newton. This is the force of it going down. So if we have the dry dock is the slope, here's the boat. It looks like a block. This force going down, pushing down along the dry dock is 4.26 times 10 to the 7th. This is not it's not the gravity pulling it down directly down, but along the dry dock. This is the text that tells me that this value is going along the surface of the dry dock. Friction is equal and opposite to this number, so it's going this way. Now, we know that the coefficient of kinetic friction is this value, 0.25, so I think we got enough information to solve this. Force of friction. That's going to be 4.26 times 10 to the 7th. Now, it's the same thing as the force pulling it down, remember? No, the velocity is constant, so whatever's going this way, the force going to the right is equal, but opposite of the force going to the left. Since this is going down, we're going to call this negative, and therefore this is positive. Coefficient of friction is going to be 0.25. Right, let's solve, because the coefficient of friction is equal to friction force. I'm just going to put friction divided by normal. We're looking for normal force. So multiply both sides by normal force. So coefficient of friction times force normal is equal to force friction. Divide both sides by the coefficient of friction. So our normal force normal, is equal to force friction. Abbreviating here. So we have this number. So that's equal to 4.26 times 10 to the 7th divided by 0.25. So let's go ahead and use this on the calculator. 4.26 raised to the 7th. Don't forget to turn the calculator on and use the exponent key. That's divided by 0.25. And you should get a value that is 1.70 times 10 to the 8th newtons. All right, and that is the normal force going up, and that's going to be positive. If you have any questions about this or the problem set, please see me after school or during Scott time. Thank you, class.